Hello, my name's Ken Kunka of Flywheel Building Solutions, and welcome to session 3, framing session including S406-16 for permanent wood foundations. We originally did this on February 12th, and we are recording it now with some revisions to the slide deck. As part of the city's commitment to improving the permit process and communication with the building industry members, the city will be providing 5 online sessions to review local building regulations, the 2020 National Building Code, and overview on the building permit process and their continued improvements. This presentation is conceptual and for information educational purposes only. Material presented must not be considered complete or exhaustive. Code provisions have been generally represented and may not reflect all provisions. What I'm trying to do in this video series is just remind you of you participating in these videos and presentations of these parts of the code that I feel are critical. And it's really up to you as an industry group to go into the code and read in more detail. So our workshop series in January of 15th of this year, just a general overview with excavation, and the February 12th, we had recently just recorded the March 5th fire protection. So please also review that in our video series with the process of developing some guidelines, bulletins related to the permit process and a better understanding of how that relates to plans and inspections leading into occupancy. So we're hoping to have that mostly done by the end of March of 2025. The workshop series content, I like this. This is from the illustrated guide. It breaks down the major categories within Part 9 within 5 groups. So use and egress, fire protection, building structure, environmental separations, and building science. We'll be mostly in a few areas here for framing. So it relates into these sections here of building structure. So we're just going to be concentrating. So keep your mindset in that area. The workshop series is part of our reference material. The workshop sessions along with updated PowerPoint presentations as we move through 1 through 5. There's some new bulletins that to be mindful of: the truss design, permanent wood foundations, and cast in place ICF foundations, and continuing updates on the city's website. So I provided you a link here. Learning objections in this session. Again, to look at the code in general and to dig into some of the specific requirements within and related to framing. So we have code requirements related to framing, site safety items. It's a big reminder for both the building officials and our industry partners to make sure sites are safe, minimum drawing requirements, minimum inspection requirements, and when professionals are involved, because those have been updated a little bit along the way in the last 12 months. We're going to dig deeper into 9.3 material systems and equipment, 9.4 structural requirements. So just a little bit of back history, why it's in the code, and some basis of moving forward on developing the wood frame foundations, columns, and wood frame construction. I was going to develop a little bit more along the above ground flat insulating concrete formwork, or ICF, but I think what we'll do is work on a separate guide related to that. There have been some staff concerns brought to my attention, and hopefully have covered most of that within the webinar series, and in particular this video. So we have deck beams that cantilever. They're typically not allowed. Decks lateral support. That's a big issue on failures, which we'll go into in depth. Decks that have cantilever joists follow code requirements. We have 2x8s, ledgers, cantilevers. So we want to talk about that. Beams that go over garages to pick up a second floor exterior wall and trusses, or it may just have a 2-foot floor load, but an exterior wall and gable. So just the relations of picking up point loads in relation to the walls and roofs around them. I'll try to go over that. The learning references in developing this webinar series, obviously the building code itself, the 2020. There is an update on the housing and small buildings illustrated guide. So I've pulled a few of those diagrams, but this is a great resource document for you and anywhere using the National Building Code. We have the BC House Safe and Durable Wood Decks and Balconies. That's a great guide on building better decks and balconies. So I'll provide some reference points to that. Canadian Wood Council Span Book and a prescriptive residential exterior woods deck span guide. as I was going through some of the other guides, I was referring to this older document here related to decks. There have been some questions related to the span book, but within the National Building Code, within the appendix note, it actually makes reference to it. So I think we're in good standing in using this little document, this little book here, which is actually not a little book. It's actually quite thick. As we go along, I've been using a reference house that I've been slowly building out, and this will be the reference house that we'll use in developing the guide in related to good drawings and how those drawings relate to inspections out on site moving into occupancy. So it'll be a two-story over a basement, a single-family home with some decks. Obviously using climate conditions of Whitehorse, soil bearing capacities, that's its minimum 75 kPa within the code. Standard load bearing, nothing very special about the design in itself. Dimensional lumber, permanent wood foundation, but we also like to look at an ICF design as well. And, typical strip and pad footings. And like I had mentioned on the last item here, we'll look at some ICF components as well. Typical building permit process. So just as a reminder, the development permit review process has provided a parallel process for up to 3 units. So I just reminded you of that it used to be a two-step process and now it's a one-step. But challenge is ensuring communication between both parties, both the planning and engineering and the building department review, especially as revisions are either required or provided, just ensuring that the parallel review process doesn't break down moving into issuance. It's critical to ensure that the BP application is filled out and all the required information has been provided. Please read the application package in full to ensure all the required information is provided in 2025, so this year, to improve the efficiency of the plan review process. If it's incomplete on the application side, it will not be accepted. Please note that the BP, site plan, and lot grading information should match your building permit drawings. And when you deal with different structures, perhaps even retaining walls, but particularly in garden suites, they will more than likely require a separate permit. Referring to the city's permit checklist guide is of critical importance in developing a good permit package, and all drawings should provide enough information to show substantial compliance to the code and city regulations, which help reduce the turnaround time for the review and help and reduce requests for further information to ensure compliance. And please apply early. Do not wait until the end of the spring or early summer if you are planning a project in the summer. There's a lot of volume coming in, and just to ensure that, particularly with some of the changes in processes, that nobody is left caught with an extended review time because of volume. Building permit drawings. It's important to ensure your foundation, your floor plans, and your sections and your details clearly show framing systems to be dimensioned clearly, location of all walls and point loads to the foundations, your joist, rafter, truss, beam sizes, and your layouts are provided. So those are your manufactured layouts of your floor systems, engineered floor systems, or your truss systems, and making sure those point loads and bearing details are clearly shown and reflected in your design drawings. Any required bridging or blocking is shown, and any manufactured beams, lintels, roof trusses, again, making sure all those components that are third-party shop drawings are transposed into your design drawings. These items may be submitted prior to the request for a frame inspection. So that matter that's noted at the end here is like part of the new process is to provide those truss drawings, the floor joist drawings. They don't have to be sealed, but when you move out into the framing process, you do have to provide sealed truss packages at the framing time for a proper inspection to ensure that all the engineering components meet minimum standards. The building permit application professional involvement. So I'd highly recommend reviewing the website and these bulletins here outlining the new requirements. And also reference the building bylaw 9950, which I believe will be updated sometime this year into next year, just keeping up with the changes in our industry. The factors for the city requiring these increased involvement for engineers. The new house designs are narrower. Our subdivisions are different now. They're narrower lots, they're longer lots. You have open plan layouts with larger point loads outside the scope of Part 9. We have an increase in engineering building components and proprietary products that are not listed in Part 9. And the soil conditions can create concerns related to the safety, bearing capacity and drainage and backfill. And in some of our newer subdivisions in Whitehorse, the soils are a little bit different and creating some concerns already regarding bearing capacity and frost action. Quick review again with climatic data in Whitehorse. So we're in the climatic zone 7B, just a reference point on our snow loads. And it's interesting for myself, working down here in Summerland, British Columbia, and then coming up to Whitehorse, and then looking at climatic data. The snow levels are actually quite light compared to other parts, I would say here in British Columbia, and particularly where I am in Kelowna. So it's not really a concern of snow load and rain loads, that even though the climatic conditions, from my understanding, are changing a little bit, with perhaps more snow or wetter snows. So these are the mindful things, or the things to keep in mind regarding your design when you're looking at your climatic and seismic information in Appendix C. So there's our snow load. So we have an roof load, 2 kPa, and a rain of 0.01. Again, fairly light. And our hourly wind pressure, which will probably come more to a concern as codes are updated and we look at more lateral load bracing for wind and seismic. And speaking of seismic, right now, as the code stands and your seismic data within the Whitehorse area, we're not really concerned about this. And I'll touch base on it one more time as we close up the seminar today. So so no additional lateral bracing required right now, but I just want to touch on that one more time as we move through the slide deck. Some defined terms: braced wall band and braced wall panel, not necessarily right now, but again, I think as we move through the summer and the new codes are being looked at updating into 25, 26, again, this may come into play. You have your dead load, that means the weight of all permanent structure and non-structural components of a building. So that's the dead, your superstructure. That's your gravity loads that you're thinking of when you're looking at the building and designing your spans and loads accordingly. You have your live load, means a variable load due to intended use of an occupancy. So the people in that, or the type of use, you could have different. So in different building types, as you get into commercial operations, they have a different load parameter than a residential. So that's the occupancy type. Assume the design and structural members of the building includes loads due to cranes and pressures of liquids and containers. So again, these things that come and go are in it. Again, snow, rain, those are live loads as well. We have load bearing. So thinking about our structure, we have non-load bearing walls, we have non and load bearing walls, and they have different parameters. And we'll go over some of the charts later on, as particularly regarding wall assemblies. We have a rim joist. That's really the only defined term. When you get into the details of framing, it means the outermost member of the flooring system, other than blocking, be it parallel or perpendicular or at an angle to the floor joist. A rim joist in the field, rim joist may also be referred to as rim boards, headers, and header joists. So there are a mixture of terminologies. And I typically would throw an unsafe condition because that gives some allowance for our building officials to determine potentially unsafe conditions, whether a permit is required or there is an unsafe condition during the construction process. The numbering, and you'll notice at the bottom it says the BC code, and that's my bit of my typo on there, but this section is just as a reminder that as you go through the code and we talk at presentations, or you talk with your building officials or other persons in the industry, sometimes these can get mixed up. They're not super important, but it is good to understand the parts, the sections, the subsections, and at least the articles as you're talking about code. 9.3, materials, systems, and equipment. The materials, systems, and equipment commonly used in the construction of buildings are covered by standards prepared by various organizations. These standards were referenced throughout the NBC of Part 9. NBC Section 9.3 was developed to provide requirements specific to these basic construction materials, and namely concrete, wood, and metal. In relation to framing and above flat insulating concrete formworks, we have 9322 lumber grades. We have a review of moisture content on undersized lumber and termite, and particularly in decay protection. Grading marking, lumber for joist, rafters, trusses, and beams, and the uses listed in table 9321 shall be identified by a grade stamp to indicate its grade and determined by the standard grading rules of Canadian lumber. It's really important to understand that. And when you look at the right side here of the screen, we have framing. And the nice thing, we have all species. It's not definitely looking at a particular type of species, but you do have to be cognizant of the standard or the quality of wood. So we have number 2, number 3 in economy and where those are being used. So that's the main thing I wanted to talk about here. And again, when you look at the labels, there's two different kinds of labels. There's just your basic grade labels, and on the right, you have your machine graded, which is becoming more popular, particularly with trusses. And when you look at your truss specification or when the building officials do, there actually may be call for manufactured or machine stressed rated lumber. And that's important to make sure that that is on there and it has been provided. And really on the left side, you look at your species. So that's number 7. And then you look at your grade, which is number 3, so on the right side there. So you want to make sure that your species and particularly the grade of lumber is adequate for the type of element or the wood that you're using in that system. Machine stress lumber, we just went over that. It's defined in the code, 9324, an outline of our OSB, wafer board, and plywood marking. So again, those all have the same similar types of marking. But the most important, I think, that I had noticed when I was up in December and a bit of a concern for myself was the moisture content. So the moisture content in the wood being delivered on site should not be greater than 19%. However, that should also be maintained through the construction process. And what I was seeing in the winter months was a lot of heat going in, a lot of heat that had a lot of moisture in it because of probably the propane or whatever was being used. And you could see a lot of frost actually building up in the walls. So a huge concern of, once the framing inspections are all completed and you're moving into insulation and vapor barrier and air barriers, you could be locking a lot of moisture in there if you're not taking particular precautions for that. So again, the maximum moisture content permitted for lumber at that time of installation is 19%. That moisture level, more than half of the wood's normal shrinkage will have occurred. So again, that's a big part, especially if you're building higher buildings in wood, and you can get a lot of shrinkage in the horizontal. So not in the vertical part of a stud, but a plate. A plate could shrink from anywhere from an eighth to a quarter of an inch. And you can imagine after a number of stories in wood, even a 3-story house, and you have a deck that's attached to it and has vertical posts, that you can see there's a significant change in the way the building is shrinking and drying if it's at a higher moisture level. Plus the issues of just having all that moisture locked in and then being sealed up, that could lead to some pretty significant mold and then eventual structural damage to it that we experienced here down in BC a number of years ago. Not necessarily termite we have to worry about, but we do want to be cognizant of decay protection. That's why there's minimum requirements. I know a lot of the wood being used up in your area particularly for foundations is permanent wood, but when you have other elements like a deck element or you're framing above above your permanent wood foundations or your ICF, there is a minimum level that you want to keep it at if you want to just use standard dimensional lumber, non-treated. So that is the 6 inches to 150 millimeters. And then, again, the structural wood elements should be pressure treated. So that's at 6 inches. And where the wood elements are not protected from exposure to precipitation. So you may have, again, an open deck, a draining deck, a configuration conductive to moisture accumulation. You have some really odd designs, modern designs coming in. You have butterfly style roofs. You have roofs leaning back towards the building itself. So those can hold moisture. We have frost action too, that we talked about a couple times now that can actually direct moisture back as well. And thankfully, at least we don't have a moisture index to worry about here. There are many above ground structural wood elements where precipitation is really trapped and drying is slow, creating conditions conducive to decay. So again, those elements where you have really elaborate detailing and you're not really thinking about the flashing and how water and snow can get in there. And again, your grade clearance as well can be a problem. When you're cutting your wood, particularly with your pressure treated materials, you have to take particular attention to those, and that is outlined within the standard, the 406 standard, and the damp proofing materials. And this is something that I'm learning more about is when you're looking at your your permanent wood foundations, there are some parameters to that, and you want to use a standard in conjunction with the code. And I'm not super familiar with that and the detailing of that, but I am quite familiar with concrete and ICF, and you have to take in particular attention when you're backfilling, not damaging that damp proofing, not necessarily worrying about waterproofing, but you have to be really careful on how you're protecting those wood elements in and around the ground. So again, take precautions for your finished ground levels. Also note the cladding clearances protect against in-floor your floor and wall assemblies as well. So if you're not getting your grading clearances, so the minimum would be 6 inches or 150 millimeters for your wood elements. And when you go into the cladding parts of the building code, which we'll cover in session 5, our last session for building envelopes and mechanical design, you're allowed certain clearances. Your manufacturers will have clearances. I believe your hardy plank is a manufacturer requirement of 6 inches. So you want to be really careful because you don't want to get those elements wet because then it'll transfer moisture into the building envelope itself. The structural requirements, 9.4. We're just going to touch on these 4 elements or 5 elements here. 941, 9442, the specific snow loads, platforms subject to snow loads, so your decks and decks uses roofs. Part 4, roofs and solar panels, and this again touch base on the changes that have been happening regarding engineered trusses and permanent wood foundations in engineering. Structural design requirements and application limitations. Again, a lot of my sessions are just talking about code and showing you code. So I just want to make you aware of where it is in the code and really ask you to go into it and really get a good understanding. And I look at item here, 1C, be designed in accordance with part 4 using the loads and deflection and vibration limits specified in part 9 or part 4, where wood framing is designed in accordance with clause C1B or C, and where supporting wall framing and fastenings or footings are designed according to clause 1A. So you also notice in a lot of the code, they're back referencing, they're saying except for, so just be mindful as you're reading through this, that you're also cognizant of other parts of the code or another standard. Again, here we have CWC 2014. So as you go through particularly structural building products that you want to look at these, and really we're dealing within a specification of loads. And in this one, in the last sentence here, and it's highlighted, shall not exceed 2.4 kPa or 50 pounds per square feet. So again, there's some limits on the loading, dead and live loading here. And this is an example of the specifications to keep you within part 9. So designing a true part 9 home. And again, homes are a lot different than they used to be. They're narrower. They are more open floor plans. They have more point loads. They have some more detailing in it that makes it difficult to keep a lot of these projects within Part 9. So Part 9 here is specified loads. We're dealing with very standard construction. You know, the subsection applies to light framing construction, whose wall, floor, roof planes, and generally comprised of frames and small repetitive structural members. Again, keeping it very simple. The whole part of Part 9 was to have basically a homeowner do this. So the structural design should be very simple, and a lot of it is prescriptive in Part 9. The roof and wall planes are clad, sheathed, or braced on at least one side. The small repetitive structural members that are not spaced more than 600 millimeters or 24 inches. The clear span of any structure does not exceed 12.2 meters. I believe that is 39 point something feet. So when we're looking at trusses and you build your homes or your Part 9 buildings, those could be commercial as well. You go over that line of, getting to 40 feet. You're now kicking that from a Part 9 type structure into a Part 4 design. So the engineered trusses, if you have, say, a 42-foot wide building and you don't have a center bearing point in that truss, you're going to kick that into a Part 4 component. And some other parameters and some design guidelines here on the left. You also be cognizant of where we relate to in the building bylaw and where engineering. So at times, again, it may look like a Part 9 building, but it is complex in nature. And this bylaw allows for the building official, or this part of the bylaw allows for the building official to get an engineer involved in either a component design or an engineer record and design, and where site conditions and size. So again, where site conditions and size and complexity of a building or part of a building or the building component warrant, the authority may have jurisdiction, may cover again the design and then the field review of it. So that's the allowance by the building official to look at this, even though we all want to keep it simple. And we want to move through the permit and inspection process. Again, our buildings are becoming a little more complicated. Our soil conditions are becoming a little trickier to deal with, and why these changes involving more engineering is happening. So when we look at structural requirements and we look at roofs, so we have Whitehorse, a specified snow load, and that's at 40 pounds per square foot. And this is the calculations within the code. We use, so we have the specified snow load, which is found in our climatic data in the schedule that we referenced a few slides back. And then we have a rain load, and there's a ratio, and the ratio is used by the entire width of the roof, or of doesn't exceed 4.3 meters. Then you're kicking over. So we have 0.45 and 0.55. So that's important to determine. Thankfully, we don't have really heavy roof loads, but when we get into the situation where we have decks, and decks shall be considered as roofs, at least we can consider these both the same because of the 1.9 kPa. And this is what I was talking about. Balconies, decks, and other accessible exterior platforms intended for an occupancy and subject to snow loads shall be designed to carry the specific snow load of 1.9, whichever is greater. So subject to the snow load shall be designed to carry the specific snow load of 1.9 kPa, whichever is greater, where the platform of each segregated area of the platform serves a single dwelling unit. Again, a dwelling unit. So it's important to keep that in mind. And again, here's an example. I actually I'm not sure why I use Abbotsford, but I did, because it's, again, very similar in the relationship of what's happening in Whitehorse. And the platform subject to large loads from built-in planters or hot tubs. So if you have one of those very heavy loads, almost more permanent, they are temporary. A hot tub is temporary, but they are a structure. You'll definitely need engineering on that. And there's some appendix notes in there. The NBC, as well as the BC has now done a more thorough review of how solar panels affect roof loading. And there's some newer parameters that have been built in regarding design. So we're seeing that. I did see solar panels up, and it makes all sense when you have a lot of sunshine in the summer. You might as well take advantage of it. But the solar panels, even though the photovoltaics are very light in themselves, and they may even run parallel to the slope of the roof or flush to the solar panels, and that's that little picture on the right side. They do have the tendency to, for wind drift, collect snow. They collect snow under the panels, pretty if they are actually a little bit lifted up. If you have a lower slope and then the panels are being tilted up to get that maximum solar gain angle, those can create some significant issues. The other issue too is if you have certain types of roofs, you have metal roofs, and you want to put those type of snow breaks on there, they can actually create a significant problem of holding snow in a position where it was never really designed properly. So you want to take those in consideration when you're designing your attic specifications in your roof layouts. Attic. So this is one of the newer bulletins that was created by Richard and the team, and a good explanation of this isn't something new related to trusses. This information, and I may have in here, yes, trusses required an engineering seal design. This information has been in code for a long time, and this is made of components, and it's made out of connectors, metal connectors. And there's nothing within the basic parameters of design of Part 9 that would allow a building official or designer or builder to, they used to have, way back in the day, used to have designs of taking wood plywood guskets and laying out the members to build a fink or a howe truss. That's no longer within the code. And because they are very specific in their design, and they need the engineered, they need a layout of the roof system, and then particular specifications for each type of truss or girder truss. And again, that has nothing new. And that's why the bulletin's going out just as a reminder, related to that. And just another, again, roof truss connections. So those are the connectors, the metal connectors, and they're very specific and they have to be designed properly to do the jobs to do it. And they are a part four component. Permanent wood foundations. And I think the main thing we want to talk about here is, again, is permanent wood foundations been used for a long time. In the Whitehorse area. The thing has really changed is the soil conditions that they're now being placed in with the new subdivisions and the pressures, the frost movement that is getting into them, and and in some of the design elements as well in these newer buildings, um, that's where we have these triggers. So again, what's been outlined in the bulletin is these are the standard, and we talked about this a few slides ago. These are the standard prescriptive elements of Part 9 and how to design the components in here related to spacing of wood elements, the type of wood elements, and how those are put together. And now we're getting beyond the parameters where Part 9 can be worked with, or even the standard, and that's why more engineering is required for permanent wood foundations. I myself was involved in a couple incidences with WorkSafe or poor WorkSafe methods as a young person moving into the construction field. And as a reminder, we do want to make sure that your workers are safe on site, but also making sure that the building officials are safe on site. And they can refuse work if there is an unsafe job site. And what it really starts with keeping somebody on site that is overseeing what is happening. So that is really important within these regulations that somebody has to be responsible to be on site. And when you're calling inspectors or calling inspections, that you should make sure, or that person should be making sure that it is safe, whether it's snow removal, ice removal, the job site is clean. There's no unsafe areas walking around in the framing component. So here we have fall protection, but not necessarily fall protection. It's more probably having your temporary stairs on a project versus a ladder, because technically a building official should not be going up a ladder. You should also be making sure that your framing component, your framing openings. So if a building official or anybody in your work crew on site is looking up, looking at a truss element, that they're not going to fall down an open set of stairs, whether they've been removed temporary to low drywall or not. Those things have to be in place. And even in here in your standards of work safe compensation, they outline trusses and the proper erection of trusses and make sure it's safe. And ultimately, as I noted on the job site, is the housekeeping, making sure it's very clean on site and there's no tripping hazards. Columns 917. Columns transfer beam loads down to solid bearing. In basements, columns carry the load directly to the footings, which distribute the concentrated loads over a wider area. The beam loads depend on the type of occupancy, the size and support, floor or roof assembly, and the number of floors to be carried. So, we have a picture here. It's supporting one level deck. The drawing that I'm working on is going to carry at least two levels and maybe even a roof. And as we look into here, as we look into code, there are some limits on how these columns are used. So we have in B, we have beams, headers, joists. So you have a column that's carrying the beam or header joists carry loads from not more than two levels. So we have two levels of wood frame balconies, decks, or other accessible exterior platforms, or one level plus a roof. And you'll notice in one of my drawings, and I'll bring it up on the next slide or two, is that I have two levels of deck and a roof. And again, that could create some issues on keeping that within Part 9. The support length of joist bearing on such beams. Again, there's a limit. There's always a limit on what you can do, and it's very important to understand the limits of, again, the spacing, the length, and the type of materials that you're in. They compound each other. And in here, the sum of the specific snow load and occupants loads does not exceed 4.8, which is higher than our 2.4 that we referenced there. So again, a slight change, but always referencing. And from on the left, back on the left side, where is the height limit found for a single vertical element of an exterior wood column? I don't believe there is on the length, but again, it looks at these parameters here, and I think we're dealing with some common sense as well, because that deck could be moved to the second level and have that column double in size. And that's where we get concerned with lateral load and failures. The other thing really important to remind you in the design and building communities, make sure the columns are centrally located on the footing. A lot of times they're off center, and when you start getting some larger loads that we'll go over in a couple examples, it's really important to set these in the middle and not have it too offset because it can create some problems later on. So just a reminder on that one. Lateral support. Because the NBC does not provide prescriptive criteria to describe the minimum required lateral support, constructions are limited to those that have demonstrated effective performance over time and those that are designed according to the NBC Part 4. So an example that they've given here, and this is taken from the illustrated guide, verandas, of the early 20th century homes provide one example of constructions whose floor and roof are typically tied to the rest of the building. So there's a bit of structure to we talk about lateral loading and loads being transferred to different superstructures. Large decks set on tall columns, however, likely to require additional lateral support. So again, thinking common sense, over the years, what we'd want to do is probably put some knee bracing in, keeping our column spacings smaller. Not you can design for larger spans. We talked about that in session 2 with our footings. There's a prescribed way of doing that, of a ratio of prescribed column spacing in the code standard is 3 meters, but you could go 4, and there's a ratio for that. But having them closer together and having some other types of bracing, knee braces, really helps that lateral support. Wood columns. So this is a prescriptive of both interior and exterior. Mostly, I would find in the rest of my province here in BC and the rest of Canada, you're not necessarily using a lot of wood on the exterior, especially below ground. But this is an example of a built-up column. So that diagram on the top, which is taken from the illustrated guide, you're going to have your treated materials. It's going down to a footing, and you may have to make sure all those connector elements are meeting all the required standards for using that treated material. But this part of the code actually tells you the minimum sizes in here and why we tried. Sometimes you'll see a 4x4, you'll see a built-up post that's only 2 elements, and that creates a problem because it doesn't provide a lot of, again, lateral support and a lot of material to tie in a beam and a post connection in here. And they're very prescriptive on the built-up columns. So because when a wood column is subject to a vertical load, so that downward gravity load and live load, it's resistant to buckle depending on the slenderness of the ratio. So again, as a column gets taller, there isn't really, and it's too bad, there isn't a prescriptive requirement in Part 9 that allows you just to beef up that column. So maybe you go to an 8x8 or a bigger built-up beam as you go higher. My understanding, there isn't in that. And that may be a call for a building official to go, well, I don't really feel comfortable with a 2-story deck assembly at these spacings, and even though we're going to add some bracing and knee bracing support, that may trigger an engineer involvement in that. The larger the slenderness ratio, the greater the tendency to buckle. Therefore, if a column is built up with a series of wood members, it will not be as strong as one piece. That's pretty obvious, unless the individual pieces are joined to act in unison. And that's why it's really important, the nailing and bolting. And it's interesting, I'll probably bring it up a few times, there is no reference to screws when you're dealing with these type of structural elements, but I know a lot of screws are being used out there. There's a lot of great products, including Simpson Strong Ties. They have a lot of great products, but it's not really prescriptive. And that's where it gets challenging as a building official to look at all this proprietary product out there that's not listed in the code. We're just going to go through a really quick layout example. This was an example used in the footing in session 2. So a 2-story house over a permanent wood foundation. It's not a very big house, 24 feet wide by 40 feet long. It's a attic truss. So, the attic, it's an engineered truss system with a attic space. It's not a living or, a storage space or anything like that. So very standard. And we have concrete basement slab and we have concrete footings. So this is a very simple example, but I did want to show that something could be happening down in the basement that we want to take into consideration. I'd mentioned before in our footing session in session 2, you do allow for some ratio to spread these out. And this is how it lays out in this element of loading. So as I explained, we have certain particular dead and live loads, and they're concentrated in particular areas of, and I may show this one here in the pink in the center. So we're taking basically half that floor joist is moving to the outside, the exterior walls, and moving to those components and those structural bearing points. And the rest is moving down to the center point of our columns in this area. So just a reminder again, how we find the dead loads, how we're sizing these elements in itself, and then taking these design loads for the footing designs and how they transpose to columns. So the framing layout is tied to the footing and the column design. And even though you want to increase your spans, you really have to look at what you can do on the footing side of things in particular. And we look at the footing sizes. And I had mentioned this example here of this design I'm working on. Can this two deck design both in a footing design, and we're going to go over that at length when we get into the guide, and that may trigger engineering, or just the level in itself of two levels of deck and a roof may be problematic in itself. Remember again, when we're looking at this design of multi-level decks, that we have limits, and those limits are in 917.11. And always ensuring that it's centered on the post and the columns. And then sometimes you may be using a concrete pier type column. I don't think that would be used very often from what I see, but there actually are maximum height limits to those. So if you have a concrete footing and a concrete pier, and then you have your saddle and then your wood post element above grade, there actually is a maximum length of that pier column based on the dimension of the width of that pier. So if you have an 8-inch pier, concrete pier, and it can only go 3 times, so you can only go 24 inches vertically. And again, because concrete is designed in Part 9 to be unreinforced and to be very simple in its uses, and it limits the spacing of those as well. So again, even though you may be able to take a wood, so you have your post and then especially your wood beam, your built-up beam may by the span book be greater than a certain amount of length. It cannot actually exceed some of the parameters within the piered foundations on that. And I'll add one more slide into this as I repost it online. Wood frame construction in general, the platform framing is most commonly used is this element in here. So we have platform framing and we used to have balloon framing. And we used to have some really significant element in protecting against fire. And we talked about that in 910 in the video series and slide deck. And that is that balloon framing actually creates this avenue of heat and fire and smoke to move through the exterior walls because there isn't that element. And you can see here on the right side of the garment where that fire blocking isn't in place. And again, we go over that in the fire protection session in quite detail here. So again, just the history, we used to balloon frame. I think some of that, it may be coming back to use some more wood and higher structures, and there's be some better guidelines on it, but we're talking about platform framing as a whole here. Framing without an engineer, again, just repeating what we talked about in 9.4. It's brought up again in 923. This section applies to construction where walls, floor, roof planes are generally comprised of lumber frames, a small repetitive structural members, or engineered components. So you may have some engineered components. You may have one or two beams. Again, your engineered truss system is an engineered component. And I think over time, we've just realized that the general floor layouts provided us by building suppliers and the truss layouts, as long as, again, they're engineered and those engineered specs are sealed, then we can use those in our whole Part 9 package without getting too much engineering involved. So 24-inch on spacing, construction does not serve foundations. The specified live load, supported subfloors, and framing does not exceed the 2.4 kP or the total live and dead load of 50 pounds per square foot. And where conditions exceed any of these items above, we're looking into the framing and fastening shall conform to 4.3. So again, moving this into Part 4. And the last item that I forgot is the span of any structural. It's 12.2 in that matter of the trusses, being careful on your building spans and how the bearing points sit. You don't want to exceed that 39.8 feet. And if you have a house again of 42, you're kicking it 42 feet, you're actually kicking into engineering. And just the other matter and reminder of 4.9 meter is the maximum joist span for supported span. So joist supported span. So that comes into play with your foundation system. So if you have a joist span exceeding those, then actually the foundational supports have to be engineered as well. So you always have to be thinking of your foundation and your framing elements working in um, connection with each other. The foundation types. So just a few slides. A reminder that we're working off S406-16 and it's reconfirmed in 2021. And there's also another guide by the Canadian Wood Council related to permanent wood foundations. Permanent wood foundations are outlined within the National Building Code, and this is the specifications for this. So both for foundations and wood frame floors. And you'll notice at the end, this is a reference point within the first part of the National Code. So this is a standard specification of permanent wood foundations for housing and small buildings. And these are the specific items within the code that relate to this here. So not a lot, but these are the two that I listed here. Permanent wood foundations, again, looking back at the appendix notes of the code, it's very repetitive. We're looking at the design parameters that you can use this standard and some of the code elements in part 9. And once you go over those, and that's what that bulletin that was created by the building department, if you start going over these point elements, that's when it requires the engineering component part to it. So we have preserved wood foundations, the design assumptions. So we have a soil bearing capacity of 75 kPa. And in session 2, we determined that the minimum standard or minimum bearing capacity that we're working off in the code is 75 kPa or 1,566 pounds per square foot. So that's our minimum. So it's really, again, important to understand your soil conditions. And in the older parts of Whitehorse, we're probably dealing with more gravel, more denser materials, materials that weren't quite susceptible to frost action or very wet conditions. So really have to understand the bearing to understand your footing design to understand everything else above it. Again, same parameters of floor spans, clear spans. So 5. So we're talking about 4.9. We have 5,000 or 5 meters. So we're very close in that parameter when we're developing our designs of maximum joist spans. Floor loadings, again, very similar, 1.9 kPa. There are some maximum wall heights to be cognizant of. So again, some design elements may be changing where we're exceeding the minimum requirements, and I've outlined a few of those here. So our design loads and our foundation wall maximums there, and then our loading. So again, just being very mindful of we're dealing with part 9, we're dealing with a permanent wood foundation standard, so falling within those standards, but they do ultimately set some limits to the structural design elements that you can use. There's really great details within the standard itself, and that's where these two are here. And we look in the standard itself buildings. So there are, again, some limits similar to part 9. We're having a building of 3 stories max in building height and a building area exceeding not more than 6,000 square meters or 6,000 square feet. The standard provides for the optional use of wood sleepers, poured concrete slab, and suspended wood basement floors as components of the permanent wood foundation and for use of the permanent wood foundations enclosing crawl spaces. So a lot of latitude on how you can develop that, but some challenges as well, and making sure that you understand the detailings within the guide and also how that relates to part 9 framing components. And that's why I wanted to bring this side up, and I believe staff want to do so. One, there is a great benefit, obvious benefit for using permanent wood foundation, but there are also some limitations. So we have a benefit, again, building in cold weather application, it's trade centric. So you have your same crew that's building your wood framing components above grade is likely the ones also doing your subsoil permanent wood foundations. And perhaps even a lower cost, particularly the building in the off season and needing to introduce hoarding and heating. But we also have some challenges. I mentioned those. So in the guide, it outlines backfill and soil problems, and we're running into some soil problems. And so again, that's why we're looking at more engineering in the wood elements of permanent wood foundations and ledgers. This has been something that's been brought up to a couple times by a number of different inspectors is that you can see in this detail is that they're having this framing component that's elevated above your granular material, which is allowed under the standard and outlined. But it mentions a ledger. And a ledger is not referenced in this standard of the appropriate way of attaching that to the superstructure. And it's not also intended for use within Part 9 because it's not outlined within Part 9 of how to do that. There is a different way of doing that, is extending the joist to the frame elements and using a ribbon board. So you typically would put a ribbon board where that ledger detail, so that little drawing at the bottom right of the screen, that would be called a ribbon board, and then that would just help you set the elevation of your joist, and then your joist would be nailed. But I could see it creating some pretty significant issues when you're trying to do your damp proofing and your radon protection details if you're not doing at the slab elevation or your granular material elevation that's just below it. You could have some really tricky parts, and then you're also creating a potential area where fire and smoke, if it's generated in that lower level, can get through. And that's why you require that little, they're calling it fire stopping, but that's not the name of it. It's actually called fire blocking. So that's the other highlighted there. And again, just a challenge of the wall height limitations. And just remind you again, ledgers are not within Part 9 of the code. So you want to develop this element here that I've shown here, a ribbon board, and the joist structurally attached, and that is within the standard and within Part 9 of the code. So be very cognizant. Again, the fire blocking, being very aware of fire blocking and fire stopping, to two very different things. Also, be mindful of the details. So we're moving from permanent wood foundation to dimensional lumber, and there's some very specific detailing requirements, both parallel and perpendicular to your bearing walls, so your permanent wood foundations or your non-load bearing walls. And then when we get into the elements of creating openings, so whether it's a crawl space opening to your basement level, your crawl space, or a true stairway, there are some very specific diagrams. So you're developing a horizontal beam to prevent that movement of that wall. So there's some very specific items within the standard. And again, this is within the standard. It doesn't need engineering, as long as you stay within the standard prescriptive requirements and also those components of Part 9. And again, trying to stay from Part 9, but again, we're dealing with a lot more complex drawings and buildings out there, and the issues regarding backfill. Be very careful. And this is a precursor to what we're trying to learn here in BC, is lateral load and seismic and wind loading is bracing the corners. So be very mindful here and highlight additional fastening structural reinforcement shall be provided at the interior corner locations to resist inward soil pressures. So we have these exterior corners and we have interior corners to protect ourselves. And again, this is outlined within the S406 standard. Connections to preserve treated wood. I'm sure you're very well building in Whitehorse for a long time. This has been a code change from a number of cycles ago, that the materials now used in the treatment of wood products is different, and it actually has caused issues with the structural connector, the metal within the connector. So you have to make sure that you're using the right connectors in there. So that would go with your brackets, your saddles, your hangers, and any of the fasteners that you're using in there. Just being mindful and careful in these elements. Within 923.3, fasteners and connectors, it outlines standards for nails and screws. And then we go a little bit deeper, common steel wire nails and common spiral nails, and it gives some tables within the code about the length and spacing and diameters. It starts talking about nail spikes and staples. It talks again in sentence 2 here, nails used to comply, and again, some table standards to use, and wood screws specified in this section shall conform to, and again, some standards of these materials being used and being tested accordingly. The interesting thing is with wood screws, it is only used in sheathing and subfloor applications. So again, we're seeing a lot of screws now being used, even the heavier screws and heavier wood construction. It's not prescriptive in the code. So again, you're putting the building official and the building team in a bit of an awkward position if they show up and see all screws as the fasteners. I think industry standard that's probably good, but again, being mindful and checking with your building department on that. Framing without an engineer, again, we can use a span book. We want to ensure, though, that this, again, the spans provided in this subsection in this part of the code, joist, beams, lintels, supporting floats shall apply only where the floors serve residential and uniformly distributed live loads. So again, no point loads. So we may have some very significant truss loads coming down. Our engineered truss package comes out. You have some very large bearings, both interior and exterior. And if that hits on a bearing element such as a beam, you can no longer use the tables in the code or the tables in the span book because we're dealing with uniformly distributed loads. Sentence two, spans for joists, beams, lintels, supporting joists shall determine according to 4.3 where the supported, yeah. So again, where the supported floors serve more than other than residential units. So this becomes problematic when we're dealing with commercial buildings and somebody has added a mezzanine, a storage mezzanine, or a working office mezzanine. You can no longer use the span book or part 9 of the code for that because it's basically going to a very high loading factor beyond this part 9 table diagram. And again, supporting uniform live load. So we're kicking it back into part 4. Framing without an hinge, lots and lots of span tables in the code. And again, just a reference point where this is spans for joist, rafters, and beams. There's number pages in here. I particularly like, as a designer, looking at the span book. One, the span book actually gives you some really good diagrams of joist spans. So we have on the left joist span, we have rafter spans, we have a good explanation again what supported length and spans are, both for floor systems and for roof systems. And again, a reminder of what's outlined in 9.4 is also outlined in span book, so that the loading factors of dead loads and live loads and spans are all consistent in here. So I showed this diagram before. So we have this house that I've been working on design, and so we have a supported length. So that pink element in the center, those are your supported joint lengths. You have your joist span, which is in between. The arrows are a little bit off in this one, but in between the bearing walls. So being mindful that even if you have like an ICF wall, which are quite thick, you may only have a 2x6 plate. So that bearing element actually goes to the edge of that plate, not the wall. So you may get to the point where you're a few inches off, and that's something to confirm with your building official if you're that close in itself. But you have to be careful where your bearing point is. And you look at your roof and the engineer roof span. Span is across, and the supported length of that roof system element of the truss system is to overhang to the center line of that truss system. Going to quickly go over a few joist floor selections using the span book. In our table here, so we have a joist span interior wall. So we have a center point of 24 width building. The center line of that beam is 12 feet off the outside of that structural framing, and then moving in, and we have a slightly thicker wall. It's probably actually a 2x8 wall. They may have it we have a joist span of 11 feet. We have a wood element, so we have the species spruce, pine, fir. And now we'll go, how do I size this joist to make this happen? So this is our flooring element here. So when we look at this part, we have a 2x8. And if I look in here with some standard subfloor thicknesses and construction methods and looking at a strapping, so we have to also be careful of our strapping and blocking of how that's tying the whole system together. And we have a few slides near the end of this presentation on that. We're delving in this area where we can look at a 2x8 type, but also being very cognizant of our spanning in here. So we have 3/4 inch structural select is 11 foot 11 and 1 inch. So that meets, but again, these other elements may not. So at 24 inches, but then now we're looking at 16 inches and we're finding more prescriptive elements of 11 feet, 12 inches, 11 foot 7 for number 1, number 2 species at 3/4 inch subfloor and the strapping. So that seems to meet. Now we're looking at the center aspect here of a built-up floor beam supporting not more than 2 floors in a house. And we're developing a supported length of 12 feet, and we're looking at the maximum span. So I have maybe difficult to see here, right in the middle between our sectional and the span table is we're dealing with a column spacing of 12 feet. So we have supported length. So the supported length will be slightly less, but we're rounding up to 12 feet. And you can see in these line items here what we're dealing with, either a 3, 4, 5 ply 2 by 10 or 2 by 12. Moving out to the exterior, and kept these spacings quite small. We could expand, but then we run into perhaps some issues with actual footing design. And we had worked on some designs in session 2, but we're looking at a live load of 1.9 kPa, or 40 pounds per square foot. And we look at not only our joist span of 8 feet and what we're doing in supported length, and we're coming down here in these highlighted areas. The thing I wanted to point out when we're looking at the span book is not incised and incised. So you look at here in the diagram with the orange arrow that just popped up. It's not pressure treated, so it's not incised. And then over here we have incised, and that actually has it's uh, breaking the wood fiber, the outer layers of the wood fiber of that joist or that stud, and to allow that preserved material. So it's breaking the wood fiber and actually decreasing the structural strength of that. So you have to be very mindful what you're using, because it can make a difference. So if we look at a 2x8 at 16 inches on center, spruce pine fir, we've gone from 11 foot, or 11 foot 11 inches down to 11 foot 5 inches. So you can see it, we're losing, roughly about 6 inches there. The deck supportive beams, built up deck beams. So again, very light, very light loading. We got one level. We have a supported length of only 4 feet when a total joist span of 8 feet. So we're looking at, the grade, Doug fir, we can use spruce pine fir, but in this case, we have a live load, 1.9 to 39.7. And then we look at the supported length, and, really we can get into pretty live loads, but you also have to think, your thinner your beam is, the harder it is to tie to the post element. So that's why typically we'd probably use a 3 ply, and then using the proper connectors in those elements. And quickly go through deck and balcony designs. This is one major failure point in Canada and North America in general. And it's unfortunate we haven't been able to deal with some of the structural concerns, namely ledgers. I did do a session for our BOBC building official members. It's posted online, and I have a link here. I just recently did another one with some updated information, particularly how I mentioned we're dealing with spans of beams and posts, but also looking at the restrictions on footings and the pure concrete footings. But you can see here, and you just look at this picture, there's a common theme of the structural failures here. This is a picture or a diagram of a local authority, and this is what you'd really like to see in the design of a deck when you're bringing in a drawing. Does it have to be this detailed? No, but it has to really design some or provide some very specific elements here. The only consideration is when we look at the footing, we look at the footing, the column, and then the joist. One aspect is that, can we really cantilever that joist? And I'll go over that in the next slide or two. Where the column is usually that post in exposed conditions, probably preserved or pressure treated. And again, that saddle here would typically, that frost protection would have to be a lot deeper in this design guide, but also it's not reinforced. So be very careful that your footing, if you're showing reinforcing in there, that is not prescriptive within the national code. You can put it in there, but it's not a design element. Just being mindful as a designer and putting things on drawings that you don't necessarily have the authority to do that. But it's really, really, really important. We can't stress enough to provide that frost protection, because it creates a lot of significant issues over the cycles of winter and summers on these deck elements, and can lead to failures. So we have issues with slope stability on the footing. So here you're seeing erosion. This is a hillside development, and just over the years, it's just things have happened and just eroding. We're seeing some elements where they haven't put proper footing systems in, and they're trying to now brace things up. So it's really careful to, again, understand your soil conditions, your soil capacities, your the landscaping that's going on around it that may create over time soil movement, and then you'll see some overturning, and how we're tying back to other structural elements. This is a good picture. They actually have a lot of articles regarding decks and the proper design of decks in the Fine Home Building magazine and on their website. The biggest thing to be mindful of is the lateral loading. So you can see the deck element. These people are sitting on the deck element, and it's quite robust, whether it's planking or whether it's sheathing for your vinyl decking. That diaphragm of the deck is quite strong, but you can see everything underneath is quite light, and it's susceptible to many actions, the soil actions, frost action, improper placement of your column and the footing. They're not centered properly, so there's a weakness point there of how that's bearing. The thickness of your posts, the thickness of your beams, how those are all carrying, and how it's ultimately attached. And again, they provide a pretty robust ledger detail on the left side, not required by code. It's actually not any elements required in the code regarding decks. And as we look back at this picture here, you can see here a lot of the failures are that, particularly that one on the top left, the deck is in perfect condition itself. It just fell away from the building. So we have to be really careful how we're dealing with this. And again, probably some lateral bracing, some knee bracing would also help on stiffness of that. And that's why I'm referencing this guide. This is an excellent guide. And actually, as we challenged the developers of this guide for BC Housing and the engineers that were involved in it, they actually provided some engineering on the ledger attachment. So the leg screws and bolts. And as long as you're following this, you should probably be good. But one thing to be mindful of, and a little explanation note in here, you have to be careful how this ledger is attached to the building, and can water get in behind it. So you may even want to space that ledger out. And here they talk about in the second paragraph, fasteners should be, you know, there's ledgers, there's fasteners, your bolts, and your washers, and you have to keep those all in combination. But you may actually want to spread that away from the building, just allow, if you have a deck that's not like a vinyl deck, you have a draining deck, you allow the water to go through, because I had mentioned decay. Decay can build up in those areas over time if they're not maintained, especially if they get some vegetation, and you can start getting some significant challenges on the structural integrity on that. You also be mindful of the material it's going into, and I don't believe this guy does, and I hope it does upgrade to have actually, if you're going into a rim joist, like a 2x12 dimensional, or you're going to an LVL or some other type of marrow of the again, having the meat to go into the structural element, into creating that connection. Notching and drilling, something that I see probably more so with engineered flooring components. I would walk into a building for frame inspection and then go automatically to the plumbing areas, and particularly where your toilets and your traps are for your showers. And lo and behold, somebody would be cutting those. And those are an engineered component, and those need to be repaired to the design of an engineer, not just adding some gussets and some plywood gussets and some glue and some screws. That may work, but when we get into dimensional lines, again, just a reminder, you can drill, you can notch, but there's some limits. And the illustrated guide itself gives some really, really good outlines on it, and that's why I've included that here. So wall studs, again, you can drill, you can notch. I have a really funny story, and again, this involved an engineer, very, very, very large demising wall, a tenant alteration project where they put in 2x6 walls at 12 inches on center because of its actual size of height. And unfortunately, the tradesperson went in and they actually put their plumbing, their drain waste plumbing system in. They drilled a 4-inch hole through your 5.5-inch deep joist or studs, and they destroyed the integrity, even though it wasn't load bearing, but it was designed for its height and for a demising wall with those fire components, so the stresses of fire. So that destroyed the whole wall. So you have to be very careful, because when you walk in, and it's important to have all these done at frame inspection. Make sure all your notching, your drilling, your back framing is all in. And even when you're going through the top plates, you have to protect that structural element. A lot of times you'll see mechanical ductwork and they cut through the plates. Well, you have to some way tie that back together, especially if it's load bearing. So be very mindful of how your framers are laying this out, and then particularly your trades. And make sure you go back, talk to your trades about some do's and don'ts. And again, lead in to help them create some situations where they don't cause problems. And we talked a little bit about that in fire stopping in our fourth session. But again, if they do notch and if they do drill, let the persons on site know, so they can make those corrective actions before the building official comes out and has to write those as a deficiency. Anchorage, a lot of great detailing here. It's quite basic. So I've highlighted here, unless the structural analysis considers wind and earthquake loads, again, we don't have to worry about that at this point. And I don't think we will, because your seismic, perhaps looking at wind, it could trigger, but not seismic in itself. When we go into sentence 2, the fastener of a sill plate to the foundation shall not be less than a 12-inch diameter anchor bolt spaced at 2.4 meters, or approximately 8 feet. But we also see a lot of proprietary. You may see that's missed, and now we have a drill and we have a quick bolt. Typically, an anchor bolt is set in the concrete. It's either dry set and poured, or it's wet set, but it's not drilled after. And again, that can create problems for the building official. The box that I created in red, again, goes with the seismic, and we had looked at the seismic criteria of Whitehorse. We're at 0.38, so we're well below that. But again, it may come into play when we're dealing with wind loads, when the codes are upgraded. And down at the bottom, sentence 5, anchor bolts, again, very prescriptive, and the depths and the size and the nuts and washers, but you also want to tighten them down, because we had mentioned things shrink, the percentage of moisture content, and you want to tighten those down as you're moving into a framing inspection to make sure they're nice and tight. Diagram provides some updated outlines of this, and I won't get too much in detail. Very specific, non-specific though, when we get into columns and posts, they talk about how you need it and why you need it. Columns and posts shall be anchored to the foundation to resist uplift from lateral movement. So talking about that lateral movement and things shifting. Supporting joists and beams shall directly anchor to the ground to resist uplift. Again, we also have uplift from wind happening. And again, we get the wind gusts, so we want to make sure it's in block. There are some exceptions, and that's highlighted in sentence 3. Anchorage is not required. And again, outline some basic or very basic platform deck. So that's maybe one way in Whitehorse of dealing with these very low profile decks, is just sitting on the ground. There's no roofs above them. They're limited in size. They are not, again, attached to the structure in itself and causing that up and down action that we referred to in session 2 of the deck and the roof element of a porch, causing some pretty significant problems. But there isn't really in there. And I think, we have our saddle anchors, we have proprietary products that I think over time is known, but again, there isn't anything specific. We do have some details on screws and nails, but again, nothing specific. So it becomes a sense or part of common sense to ensure that you're tying all your vertical and horizontal elements as best you can within this, without having too much guidance in it. There is some guidance in ICF, and again, wanted to provide these details. And this is the only mention of floor ledgers, and it's floor ledgers, and it's a bottom chart here, floor ledgers to flat insulating concrete forms. We could transpose this to other elements, but again, this is specifically only for ICF construction. Staff also want to do a reminder on concrete footings within the standard and the way anchor bolts. So you do need that squash box for anchor bolts. A squash block of the same cross-sectional dimension as a bottom plate shall be nailed on the top of the bottom plate with an anchor bolt passing through it. So be, again, very mindful when you're laying out your concrete footings, and if you're either embedding or wet doweling, that you have the proper length of anchor bolt to have this element properly set up in the length that it needs to have on its embedment. Resistance of joists and of the bottom joists. This is critical. So especially in the span book, they give you 3 different elements to work, or a combination of, and that decreases because it's tying everything. So not only decreasing the deflection and bounce, but the structural strength of it as well. So you can use these in combinations and get a longer joist span in it. We talked about that detail for the deck designs. So in the code book itself, and this is the only area that can find cantilever joists, they talk about a house floor joist cantilevering, and house floor joists can actually carry a roof line or a roof load. So cantilever portions, again, sentence 1, floor joist supporting roof flow shall not be cantilevered more than 16 inches beyond their supports, and a dimensional of 2x8, and using not more than 2 feet beyond their supports where you're using 2x10. So it sets that limit for floor systems supporting a roof. Cantilever portions shall not support loads from other stories unless calculation. So again, if you're supporting more than 1 story, you are moving back into a structural part 4 design. And then if you're cantilevering out so far, in sentence 3, it should tie back. And a lot of times we don't see that, though. It's usually not 6 times, it's usually less. And I think over time we've found an equilibrium on that. But I necessarily talk about deck joists. But when you go to the span book, when you go to the BC Housing Illustrated Guide, and even in the newer document or the old document that I found more recently, Descriptive Resident, they all talk about at least a maximum, and again, it should be a maximum of 2 feet cantilever, and that's how they lay out these joist span design books. One element, and I saw a lot more so in homes built, 70s and 80s, that they'd have these little bay bump outs and they may support a small little roof above it for a dining room or a hutch. But you're not supposed to tie your structural deck elements to that. Those deck elements, the framing should tie back to the house. And then this is a good example of old school framing of squash blocks instead of hangers. So again, some many things going on that this building official saw at a renovation going, one, this may be a deck built without a permit because the way it's framed, or two, this was not really thought out well on the framing of the original house, and again, should be corrected. And you can also see it's obviously has some wood, some moisture damage in the deck element itself, and that may be caused by sagging at that element, that connection where the deck and that bay have flexed over time. Because it's not a good structural framing connection, and it's allowed over time moisture to get in there and rot it out as a decay element. There are maximums to the height of walls, and I just wanted to provide this in 92310. You'll have to be very careful of interior and exterior and load bearing and non-load bearing on this. And again, it sets that height limit. And I had mentioned that part of the demising wall and the plumbing getting drilled through those walls. Well, that needed to be designed because it exceeded it. One, wasn't a residential, and two, it included a very high wall that wasn't load bearing, but it was over the limits of the allowable. Studs. This is a newer slide from my original. I just want to be, again, very mindful of the framing components. Again, all within part 9, 923.10.6, studs on the sides of openings, or a lintel. Again, that lintel, that opening over your window or door, or your garage door, where that lintel spanning was more than 3 meters or 10 feet, studs shall be tripled on each side. And then it goes into perimeters of 2 inners, except where in sentence 2, except and provide in sentence 3, this where lintel spanning the opening is not more than 3 meters. Again, provide some outlines there. And then it talks about single studs, and that's in the diagram from the illustrated guide that are to the right of this. You do have to be very careful of non-load bearing and load bearing when you're talking about these. So again, some diagram setups here. Again, non-load bearing, and not required to have a fire resistance rating. Again, I talked about that demising wall. When you're dealing with fire, it creates different stresses on that wall element. And again, how it's tested, it has to be structurally sound. And therefore, that's why it's really particular attention to look at not only interior, exterior, non-load bearing, load bearing, and whether it's part of a fire component of fire separation. Almost coming to the end here, 923.13, bracing to resist lateral roads due to wind and earthquake. Again, just a reminder, we're not there yet, but we may see some triggers, not in seismic, which is noted on the bottom here, but we may start looking at some complications when we get into wind loads, and we'll know that more so near the end of this year into December 2025, and then looking at adoption full rollout in 2026. That's about all I have for framing, just in our time that we have. I hope I've been able to cover some of the critical areas, especially in decks and the deck failures that are happening out there, being very mindful of the structural connections in both decks and in your wall and beam and roof assemblies. Again, being very mindful of when you have engineers and when they should be involved, and when you can, again, stay in part 9, and where it's some of this gray area, you really have to be very careful. Please continue to read through part 9, 923, wall plates, roof and ceiling framing, subflooring, roof sheathing, and wall sheathing, all very prescriptive of fasteners and the type of use and spacings. Just wanted to finish off, just as a reminder, we talked a little bit what should be on a drawing. Pretty important. The drawing shows substantial compliance of the code, particularly when we're dealing with structural dimensions, sizes, point loads, transferring your floor systems. You may have a floor layout, particularly engineered truss layout, transferring all that information together. Well, when we're going out on site, we're at foundation and dam proofing. You have to be, again, what's going on above in the framing has to be transposed down to the foundation. So we have to know the foundation is set up probably, and even where the footing pads are located, make sure we don't have any framing problems. Um, and the reason I put this in here, this is a benchmark inspection. So anything that's leading up to this type of inspection, all these elements need to be done. And we're dealing with wood foundations, but we're also dealing with some leftovers perhaps of a previous inspection. This is before we backfill, we have to make sure these are all done. And ideally with the backfill, we have the superstructure started on top to create that bracing element. Framing, again, just some notes, being aware that your connectors, your framing, your back framing, we have our sealed engineered truss specs as noted on the right side there. Those are all important. It's important to get all your drilling, all your notching done to make sure that that's not, that's not an issue when you're moving to insulation and then you're removing perhaps vapor barrier to go back into the walls to create some repairs on damaged floor systems and pretty good walls that are either notched or drilled too far. We're going to look at clearances. We're going to make sure all our structural elements are done correct. And this is another, moving into another benchmark, and insulation is really the final benchmark on it. But a reminder on the bottom here, make sure your moisture content. So if you've been running into a very miserable wet spring or a fall shoulder season, or you're introducing a lot of heat in the winter, you'd be very careful of trapping that moisture in there because it is going to be problematic over time. Framing, roof and parallel core trusses, individual designs, sealed. So again, we have to be very careful of we're looking at our beam systems, our parallel cords, or trusses. Those have to be designed appropriately by a recognized Yukon engineer. Your floor, I-joists, and other engineering frame components. The requirements for seals will depend on the complexity of whether they are point loads. As such, requirements for seals will be determined and communicated as condition of the issuance of the building permit. Again, drawings come in, do the best you can as a designer and building team to get all the structural information on there. And if we're in these gray areas, you're building your official plan reviewer will reach out to you with enough lead time to try to make this happen. But try to be proactive. If you're seeing, again, a lot of big beams, a lot of point loads, a lot of complexity, you're more than likely going to need the involvement of an engineer, and that engineer of record will have to look at these shop drawings and incorporate that into there. So again, when in doubt, reach out. Reach out to Development City of Whitehorse. And here's some contact numbers for you with both the links. The next session we've already finished, and it was actually March. I found it pretty productive. We had some good commentary in it, so please go and check that PowerPoint out and the video that was created for it. And that's all I have. So I really appreciate you taking time to watch this video. And if you have any questions, please feel free to reach out to the building department at the City of Whitehorse, or reach out to me specifically at ken.flywheel@gmail.com.